Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today we are going to learn homogeneous catalyst. For homogeneous catalyst, it means that both the catalyst and the reactants are in the same physical state, right? And the catalytic activity of a homogeneous catalyst depends on the ability to exist in variable oxidation state, right? Where a homogeneous catalyst can take place in the reactions, and therefore an increase in its concentrations will also increase the speed of the rate determining step, which is also means the rate of the slow step. Alright, now we'll take a look at the example 1, which is also one of the famous past year questions. This is the catalytic oxidations of atmospheric SO2 by atmospheric oxide of nitrogen. Well, we know that NO2, which is from the car exhaust fume, can oxidize atmospheric SO2, which is a pollutant from the burning fossil fuel, to SO3, which would dissolve in the water vapor in the atmospheric to produce sulfuric acid, which is the acid rain. So let's take a look at the equation. So first step, this is the NO2 gas reacts with SO2 gas, and you will get SO3 gas and NO gas. So we will call this as my homogeneous catalyst. Why is that a homogeneous catalyst? Because the physical state of this catalyst is same as the physical state of this reactant. So therefore, this is known as a homogeneous catalyst. Alright, so continue from here. When we have this NO, nitrogen monoxide, will be able to oxidize to form the NO2 gas. Alright, and the third step is that the SO3 gas will react with water to form sulfuric acid. If you take a look at this step 2, this NO gas is forming NO2 gas. So this is the catalyst, right? Now this is a catalyst, and this catalyst is regenerating in the step 2. Okay, so how does this homogeneous catalyst work? It works by changing the oxidation number. Now let's take a look at the oxidation number for this N. Okay, now for this N, the oxidation number is plus 4, right? Because this O is negative 2, right? Whereas the oxidation number for this N is plus 2, okay? And here plus 2, here plus 4. You will see that for this homogeneous catalyst, okay, the activity depends on the ability to exist in variable oxidation state. That means it is able to change the oxidation number, but in the end of the day, the oxidation number will be restored back. So this is how a homogeneous catalyst work. Alright, let us look at the past year questions from November 1-2 paper 43. Nitrogen oxide in the atmosphere are homogeneous catalysts in the formations of acid rain. First questions, what is meant by the following terms? The first one, catalyst. So the catalyst means it is a substance that speeds up the rate of reaction. Okay, or you can mention a substance that lower the energy barrier, or you can mention activation energy. All right, now what is meant by a homogeneous? Homogeneous means that the catalyst and the reactant in the same physical state. All right, now 2 marks down. So for the next questions, B1, state a major source of nitrogen oxide in the atmosphere, explaining how they are formed. Well, nitrogen oxide can form from a few sources. It could be, number 1, car exhaust, or because of the hot engine, or we can say aeroplanes, or lightning, or we can say the burning of fuel, or power station. So how is that formed? That is because the nitrogen reacts with the oxygen. And you can also provide the equation N2 plus O2 forming 2NO. Alright? And number 2, use equations to describe the chemical role played by nitrogen oxide in the formations of acid rain. Now, we know that the role of nitrogen oxide is a homogeneous catalyst. Okay? Like I said, the first step is the NO2 gas, which is also known as a homogeneous catalyst. It can react with the SO2 gas from the atmosphere to form NO gas and also SO3 gas. Okay, now for step 2, the NO gas will regenerate back the catalyst, which is forming back the NO2 gas. And for step number 3, the SO3 gas, which is formed from here, will be trying to regenerate back, to form the sulfuric acid, which is the acid rain. Now let's look at another example of a homogeneous catalyst, which involve the oxidations of iodide by the persulfate ions. Alright, so this is the equations which involved, and if you look at this equation, both of these negative charge ions reacts to form a sulfate ions and also iodide. And one of the famous past year questions is this: the reactions is kinetically slow due to high activation energy. Suggest a reason for this. Now, these reactions happens without the presence of catalyst. Why is this reactions kinetically slow? That is because of this very important charge here. Now, if you notice that both of these ions are negatively charged, in order for this negatively charged ion to react, it requires a lot of energy for them to come close together because they always prefer to repel each other. So therefore, the high activation energy is needed to overcome the repulsions between the negatively charged ions. Okay, so we write it down. The energy is needed to overcome the repulsion between the negatively charged ions, which is the S2O8 2 minus and the iodide ions. Alright, so in order for these reactions to proceed smoothly, we will need a catalyst, and the catalyst will be Fe2+. Okay, now in order to build a two-step equation, first we'll need to know the oxidation number for the sulfur and also the iodine over here. Alright, let's take a look on the oxidation number. S2O8 minus. If you want to know the oxidation number for this sulfur, it will be 2x plus 8 negative 2 equals to negative 2. So we have 2x equals to negative 2 plus 16, which is equals to plus 14 over here. And hence, therefore, x equals to plus 7. The oxidation number for this sulfur is plus 7. Alright, whereas for the SO4 minus, this sulfur is x equals to negative 2 plus 8, and therefore x equals to plus 6. So this oxidation number of the sulfur is plus 6. And for this iodide, it is negative 1, and this iodine, the I is 0. So it is very clear that from plus 7 to plus 6, this is the reductions. And from negative 1 to 0, this is oxidation. Alright, so right now we know that homogeneous catalyst works by the ability to change the oxidation number. If right now our catalyst is Fe2+, aqueous, right, Fe2+ will be able to change to Fe3+ by oxidation. So if this ion undergo oxidation, okay, it should react with the substance that will undergo the reduction, okay, which is this to this, right? So therefore it will look like this. S2O8 2 minus plus unknown number of electrons to get this. So how do we balance this equation? Right, if you take a look closely, the oxidation number on the left hand side, which is this side, is negative 2, which means the overall charge is negative 2. And over here, the overall charge is negative 4. So we always add electrons to the more positive side, which is this side. So in order to make this equation balance, we'll need 2 electrons over here. Alright, so that's how we balance the equation. So this is my step 1, and that we will have to multiply the first equation by 2 so that I can cancel off the electrons over here. So when we have 2 electrons and 2 electrons, everything will be cancelled. And your final equations will be 2Fe2 plus persulfate ions forming 2Fe3 plus 2SO4 2 minus. Alright, so this will happen in step number 1. Alright, now for step number 2, you can see that now that you have your Fe3 plus, And we've said that the Fe3 plus is the catalyst and is a homogeneous catalyst. So therefore, it has the ability to change back the oxidation number as well. So therefore, Fe3 plus, which is in the aqueous state, so all this is in the aqueous state, okay, so continue with this Fe3 plus will be able to change back to Fe2 plus by undergoing the reduction. Okay, so now that in this step, this Fe2 plus is regenerates, which means from the beginning you are using Fe2 plus. Right now in the step 2, it is regenerating. Okay, so for this step to this step, this is a reductions. So therefore, we will have to look for an oxidations to happen. Okay, so the oxidations will have to pick the iodide, which is from 2I minus aqueous, forming I2 plus 2E. So in this manner, we will have to place times 2 over here to balance the equation. And therefore, we have 2Fe3 plus aqueous plus 2I minus aqueous, forming 2Fe2 plus aqueous plus iodine. Okay, so in other words, this is my step 1 equation and this is going to be my step 2 equation. Alright, so my intermediate will be my Fe3 plus in this case. So therefore, I can plot a graph, an energy pathway over here. Now this energy pathway shows an uncatalyzed reaction, which is just a step. But by using Fe2 plus as a catalyst, we will break down this equation, these reactions into 2 steps with an intermediates like this. So this is my intermediate. So if I'm using Fe2 plus as my catalyst, then the intermediate here will be Fe3 plus, and finally my Fe2 plus will be formed over here. Alright, that's all for today.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.